A farmer has 120 yards of fencing to enclose 3 sides of a rectangular patch of land, which is bordered by a river on the 4th side. Write a function that models the area enclosed with respect to the side length x perpendicular to the river. What dimensions would produce the maximum area? How much area can he enclose? So let's actually do a little bit of a diagram. Let's say that this is the river here. And he wants to enclose a rectangular patch of land with a fence. So it's going to be something like this. And he only needs 3 sides of the fence because the river is the boundary on the 4th side. And we want to write a function that models the area enclosed with respect to the side length x perpendicular to the river. So we're told that the side length perpendicular to the river is going to be x. And we know that for a rectangle, opposite sides are equal. So those are going to be x. Now, if we need to figure out what this side length is going to be, we can use the fact that we've got a total of 120 yards of fencing. So if he started with 120 and he used x for this side and x for this side, he's used 2x in total. So the remaining is going to be 120 minus the 2x that he already used. So we need to write a function that models the area here. Do you know the formula for the area of a rectangle? Area is length times width. In this case, the length is x, and the width is 120 minus 2x, or vice versa. It doesn't matter which is the length and which is the width. It's just that those are the 2 sides. And I'm going to write this a of x because area is a function of x. And we write functions like that. So then one more thing, this is a fine answer for the area, but I do want to expand the right-hand side. So we get 120x minus 2x squared, and it might be helpful to write it in standard form, negative 2x squared plus 120x. Any of these answers are acceptable for the area as a function of side length. But this last one is probably going to be the most helpful because we recognize that this is a quadratic function with a negative leading coefficient. And so the graph is going to look something like this, some shape like that. It's a parabola opening downward. And so what we want is to find the vertex because that will give us the maximum area. So let's go ahead and do this. So the x-coordinate of the vertex, which we usually label with h, we know that we can find that by taking the opposite of b over 2a. In this case, b is 120, so the opposite of that is negative 120 over 2a. Well, if a is negative 2, then 2 times negative 2 is negative 4. And negative 120 divided by negative 4 is 30. So the x-coordinate of our function, the x value that gives us our maximum, is going to be 30. And so what that means here is that the side length that's perpendicular to the river is 30. And then to find the other side length, we've got to take 120 minus 2 times 30. 2 times 30 is 60. 120 minus 60 is 60. So it's going to be 60 yards by 30 yards. Now, to find how much area that is, we actually have 2 options. We could find the function value that corresponds to this. We could evaluate a when x is 30, or we could just multiply length times width here in the rectangle. Let's do both to make sure that we get the same answer. If we plug in 30 to the function, this is going to be negative 2 times 30 squared plus 120 times 30. 30 squared is 900 times -2 is -1800 plus 120 times 30 is 3600, and 3600 minus 1800 is 1800. So that's going to be 1800 square yards, because when we're dealing with yards as a measure of distance and we're looking at area, that's square yards. But we can also just do length times width here. We know that area is length times width, which is going to be 30 times 60. And again, we get 1800 square yards. Either one will give us that calculation. So let's answer the questions we were asked. We've written our function. What dimensions would produce the maximum area? Well, this is 30 by 60 yards. So 30 yards by 60 yards gives a maximum area. And we were asked, what is that area? So I'm going to say a maximum area of 1800 square yards. So this is another situation where having some knowledge about quadratic functions helps us to find the best way for a farmer to enclose a patch of land, perhaps for animals to be roaming on, where he wants to use his fence to give them as much possible space to roam as they can.